Welcome and warm greetings to dear all audience. We are here again with Professor, Ambassador Professor Dr. Rania Lampu with, on our professional masterclass. Okay, and today we are into the second part of research design and methods topic, lecture number 8, topic qualitative and quantitative research. For this, I would like to welcome Dr. Rania because I didn't want to waste time. I want to give her more time to share her material. Thank you. Welcome, Dr. Rania.
Thank
Dr.
you.
Rania
Thank
is
you very much.
you can see from the poster. Yeah, welcome.
Thank you. Thank you very much. First of all, I would like to congratulate the team of Elegant Higher Education for your constant efforts to promote quality education through diverse initiatives. And of course, I would like to thank you for the invitation and the wonderful opportunity you give me to conduct this research series. I think it's very useful, this initiative, especially for beginners or those who are interested in research and don't know how to start. And during our previous session, we explored the research design. We discovered how this is this blueprint for the entire research process. The research design outlines how a study is planned, is conducted and analyzed, ensuring that the results are valid, reliable, and relevant to the research question. And we say that at each core, research design bridges the gap between actual theory and empirical observation. So we highlighted that a well-structured research design answers fundamental questions: what is being studied, why is this being studied, how will data be collected, what are the limitations and ethical considerations. And research designs can be broadly classified, we said, into qualitative, quantitative, and mixed methods, each serving different purposes. So choosing the right design depends, of course, on the research objectives, the nature of the problem, the type of data needed, and the practical constraints of time, resources, and access. So, of course, research design is not just a technical step in the process, it's the foundation upon which credible and impactful knowledge is built. And during my presentation, do you remember you stopped me and you asked me to take a particular example and present it today. So today, I think the session will be even more interesting because we will try to explore how we can design a study, how we can apply what we learned during the previous lessons today in our research design, which will focus on how we can measure the effectiveness of an AI-based learning tool in classrooms. So together, we will shed light on the research design strategies in application, how we can use, what strategies we can use in order to evaluate AI-driven educational interventions, from choosing the right methodologies, defining measurable outcomes, identifying control and experimental groups, to analyzing data with rigor. We all discuss about this. I will start sharing now my presentation. I don't know if it's visible.
I think it's. Did you upload?
Mm-hmm.
I think it's uploading. I cannot see it on the screen yet. Once it's on the screen, I will add it to the stage. Then you can. I cannot see. Can you? Why is it taking so long? Normally it's fast, right? Can you try it? Or is it uploading? Can you check the status?
Okay, let's see again. I think now it's fine.
Yeah, it's here. It's here.
Okay, can you see the change of slides also?
Yes, yes.
Okay,
yes.
okay.
You may proceed.
So, last time you asked me to focus on a particular example, a particular application, the research design, so that we can help more practically researchers. So, how we can design a study in order to measure the effectiveness of an AI-based learning tool in the classroom. Design a study like this involves careful planning to ensure valid, reliable, and meaningful results. So uh, here is the structured approach that we're going to follow. First step is to define the research objectives and questions. To evaluate an example of the objective, for example, to evaluate whether the AI-based learning tool improves student learning outcomes compared to traditional methods. This is an example of the objective that we can formulate. Some research questions. Does the AI tool improve test scores? How does it affect the student engagement and motivation? Are there differences across subjects or student demographics? So have in mind this kind of questions. Then, of course, this objective sets the stage for assessing academic achievement, but you can broaden it to include student engagement, motivation, or teaching practices depending on your goals. So this step lays the foundation of our study. It defines what you're trying to learn, why it matters, and how you will measure it. A clearly defined research objective ensures that your study stays focused, relevant, and measurable. So first one is the second, formulate research question, because these guide the specific aspects that you want to investigate. Good research questions are measurable, are focused, are aligned with your objective. Some examples of research questions: does the AI tool improve student academic performance? How does the tool impact student engagement, I mentioned before? Do student demographics influence the effectiveness of an AI tool? And some thematically classified questions are related. Here we can see with, for example, academic performance, what kind of questions we can formulate here. How does the AI tool affect the student performance in specific subjects, for example, mathematics or reading? Is there a significant difference in pre-test or post-test scores among students who use the AI tool? If you select the field of engagement and motivation, what kind of research questions you can formulate? How does the AI tool impact students' engagement during learning activities? Or do students find the AI tool more enjoyable or motivating than traditional methods? And what are students' usage patterns at the time spent or the frequency, and how do they correlate with engagement levels? Then is usability and user experience. For example, how user-friendly do students and teachers find the AI tool? What challenges do students face while interacting with the tool? Or how satisfied are teachers with integration of the tool into their instructional practices? So questions like this. In the field of equity accessibility, what you can formulate. Are there differences in the AI tool's effectiveness across student demographics, gender, socioeconomic status, or prior achievement levels? Or how do students with special education needs or disabilities interact with the AI tool? Does the tool help close achievement gaps among underperforming groups? Regarding implementation, instructional integration, we can ask, for example, how consistently is the AI tool used across classrooms, or what training or support do teachers need to implement this tool? How does the AI tool affect instructional time and teaching strategies? If we're interested in attitudinal and behavioral changes, then we can ask how does this tool influence students' attitude towards subject matter, if it has student confidence in learning or self-efficacy improved due to the AI tool, or do students develop greater autonomy or responsibility for their learning through this tool? And longitudinal impact, for example, the improvements in learning outcomes persist after the AI intervention ends. Are students who use this tool better prepared for subsequent grade levels or standardized tests? This is what we call longitudinal impact. And data algorithmic transparency. If, for example, students and teachers are aware of how the AI personalizes content, if students feel that the AI tool understands the learning needs, and how do teachers actually perceive the AI's decision making or recommendations. So the first step is to define the research objectives and the questions. So state the research objective, formulate the questions, then you add hypotheses. Hypotheses are testable predictions that give direction to your analysis, and the hypotheses typically respond to your main research questions. Example of hypothesis. Students who use the AI-based learning tool will show a statistically significant improvement in test scores compared to students who use traditional methods. This is the first example. Another example, the students who use this tool will report high levels of engagement and motivation. The effectiveness of this tool will vary across different subjects, with the greatest impact in mathematics. This is one hypothesis that we can formulate. And another one, this tool will have a greater positive impact on students with a lower baseline academic performance. So then you clarify outcomes. You must define, for example, what success looks like by identifying both primary and secondary outcomes. This helps you focus your data collection analysis. Primary outcomes are the main metrics of effectiveness. For example, we talk about academic performance. We need pre and post test scores, course grades, skill acquisition, and then we need the secondary outcomes, which are actually related with engagement, the time on task, the participation logs, motivation. So this includes survey responses, using validating scales, attendance, how we can track class attendance or participation consistency, or the tool usage metrics, the frequency and type of interactions with the AI platform. So this is how we can clarify the outcomes. And I can give an example. The primary outcome is improvement in math test scores. Secondary outcomes include increased time spent on learning tasks, student-reported motivation, and consistent tool usage throughout the intervention. So here you can see a summary table which shows the objective here is evaluate the impact of the AI tool on student learning outcomes. Some research questions, if this tool improves test scores, engagement, motivation, or other subgroup effects. Some hypotheses that we added, if students will improve or low performers may benefit more. And the primary outcome will be related with academic performance, secondary outcomes will be related with engagement, motivation, and attendance. So all these things that are necessary, these steps, these sub-steps actually, of the first stage, which the first stage is related with how we define research objectives and questions. Then the second step is to choose the study, select the study design. Here, for this particular example that we are trying to examine, what is recommended is the experimental design and what we call randomized control trial. What is a randomized control trial? When we randomly assign students or assign classrooms or students to two groups. So there is one intervention group which uses the AI-based learning tool, how we can set an example, and the control group continues with additional instruction or uses a non-AI tool. Why this is experimental design here is powerful? Because it can control confounding variables, the pair knowledge, the teaching style, and because it establishes causality, not just correlation. I give you an example. If sixth grade math classrooms are randomly assigned to use the AI tool versus traditional instruction, and test scores improve only in the AI group, then you can conclude that the tool likely caused the improvement. So this is, understand why this is um, powerful. And remember something that randomized control trials are gold standard. Of course, they're gold standard, but we need to consider also some other types of design that we're going to explore other types. The tip here is to balance practicality with rigor. Consider logistical and ethical feasibility when you choose between the random control trials and quasi-experimental alternatives that we're going to explore. So you choose the study design is the second step on evaluating an AI-based learning tool in classrooms, incorporating your notes on randomized control trials or cluster designs. We're going to see now crossover designs and practical considerations. So an alternative of this could be a quasi-experimental design if random assignment is not possible. We could have matched groups, or we can have pre-test or post-test designs. So we choose a study design, there is always an alternative. Here we have a quasi-experimental design. And choosing the right study design is crucial. Why? Because it directly affects the validity, the reliability, and interpretability of our findings. It defines how well you can establish causality between the AI tool and the student outcomes. So this is the first one. The second one, we mentioned about the other alternative, cluster randomized control trials, when individual randomization is not feasible, and this happens at the group level. For example, entire classroom or school. Why you use it? Because this prevents what we call contamination. Students sharing AI tool access or learning strategies across groups, and it's easier to manage administratively. For example, we randomly assign 10 classrooms across the schools, 5 to the AI tool and 5 to control, so students in different conditions don't influence each other. And the note here is that we need to use multi-level analysis later to handle the instant data structure, the students within classrooms. So the second alternative is the cluster randomized trial when individual randomization is not feasible. And this has to do with group level. Another alternative here for this practical example is crossover design. When each group experiences both the intervention and the control condition, but at different times. For example, the group A uses AI tool in term 1, traditional method in term 2. And group B will use traditional method in term 1 and AI tool in term 2. So what are the benefits here? That every group gets access to the tool, and students serve as their own controls, improving statistical power. Very important. The problem here is what we call carryover effects, because learning from AI tool may persist into the second period, and it's not suitable for subjects with cumulative knowledge structure, for example, mathematics. So the third one is crossover design. When we try to experience the intervention and the control condition, but at different times, and we have the quasi-experimental design if randomization is not possible. There is no random assignment here, but you can compare existing groups and try to control the differences. The common approach is what I mentioned before, the matched groups. We can match students or classrooms based on similar characteristics. So here we can use pretest scores or demographics, and the pre-test or post-test design when we try to measure outcomes before and after the intervention in both groups. What are the limitations? Is that we cannot fully control for all the variables, especially the confounding variables. Our causal claims are weaker than what was happening with randomized control trials. And an example here, I mentioned, if one school adopts a tool and another similar school doesn't, Then you can compare learning outcomes, but must control for school level differences. This is a nice example. So some tips in order to choose your design. The first one, randomized control trial, is best for small-scale pilots where students are randomly assigned. So here is the highest internal validity. A cluster, with a cluster we have larger studies is best for this when AI cannot be individually managed. So here it reduces contamination, it requires larger sample size. Crossover design when access must be equitable or sample size is small. And here means that we must avoid long-term carryover effects. And quasi-experimental when we have real-world constraints that actually prevent randomization. And it's easier to implement, but requires careful matching or statistical control. So a summary of this could be that choosing a study design is about balancing rigor with reality. If it's possible, go with a randomized control trial or cluster for strong evidence. If not, you can design a strong quasi-experiment and apply strong, robust analysis techniques to adjust for confounds. Always consider ethical issues, of course, and practical constraints. That is very important to have in mind. Now, the third step will focus on how we need to define the sample and sampling method. Here, we define the sample, we select a representative sample classrooms of the students, then we use random sampling if it's possible, or proposing sample with attention to diversity, and then we decide on the sample size based on power analysis. And very interesting, the fourth part, which is related with how we can develop measurement tools. So here, for example, for learning outcomes, if our learning outcomes are standardized tests or some specific assessments before and after the intervention, or that could be grades or performance metrics. If we talk about, for example, academic performance, what could be the metrics of academic performance? Pre- and post-test scores, standardized or curriculum-based, grade improvements over time, or completion rates of assignments modules. That would be the learning outcome, the academic performance. Okay. The first one is academic performance. Second one, we talk about engagement and motivation. Then we can use student survey questions or Likert scale. Likert scale, when we try to, for example, usually it's 5 steps scale. When we strongly disagree, to strongly agree. For example, you have questions. I enjoyed using the AI tool during the class, or this tool kept me interested in the subject, or I was more focused when using this tool compared to regular lessons, etc. Or if you have teacher survey questions, and we say that my students were more engaged when using this tool, or I observed high participation during AI-assisted sessions. And some interview prompts with students. We can ask them, what did you like or dislike about using the AI tool? Did it make learning more interesting or easier for you? Then another, sorry, here, yes, we can see the first one. Okay, well, we mentioned about engagement. Another could focus on usability and user experience. For example, the student survey questions could ask that the AI tool was easy to use and navigate. The teacher interview prompt could say that what technical or usability issues did your students encounter? And the questions also of equity. What would be the metrics of equity and accessibility? The metrics could be the breakdown of performance by subgroup, by gender, for example, or use frequency across student demographics, or the accessibility error logs, if they're available for the tool. Survey questions for teachers. The AI tool supported diverse learning needs in my classroom. Um, or interview prompts. Did any students face particular challenges in using the AI tool? Um, Another issue is related with implementation and structural integration. Teachers can formulate several questions that I see adequate training to integrate the AI tool effectively, or the AI tool fit well into my existing lesson plans. What could be the metrics here? The number of hours used per week, or teacher fidelity checklist. Some interview prompts. What changes did you make to your instruction to accommodate the AI tool? How often and in what ways did you use it? And about behaviors or attitudes, then we have some several questions. I feel more confident in this subject after using the AI tool, or feel more in control of my learning. Teachers can say that students showed more responsibility for the learning during the sessions, or I noticed an improvement in student behavior, so things like that. In terms of a longitudinal impact, then we have follow-up metrics, usually 3 to 6 months later. What could be these follow-up metrics? Retention test scores, continued use data if the tool extends into next term, and teacher-reported preparedness in next grade level. So some interview prompts. Have you noticed any lasting effects of using the AI tool on student learning? And for data and algorithmic transparency, you can say I understood how the AI tool adapted content to each student. I trusted the tool recommendation for student support, or students could say that I felt that the tool gave me the right kind of help when I needed it. The AI tool seemed to understand how I learn best and things like that. So some optional here add-ons could be the focus groups. When we small groups of students and teachers who can explore deeper perceptions, or tool analytics integration, that could be the time on task, the module mastery, hint usage, or classroom observations to validate engagement, instructional use. So we need to develop measurement tools for learning outcomes. We use standardized tests, subject-specific assessments before and after the intervention, the grades or performance metrics that I mentioned. For engagement, we mentioned again what will be validated scales or classroom observations, or users logs from the tool. Some additional data could include feedback, interviews or focus groups, and this could be expanded by triangulation when we try to use multiple sources and methods, when we try to combine, for example, quantitative and qualitative data, behavioral metrics, when we use tool-generated analytics like time on task, completion rates, or hint usage, etc. It will be useful here to use validated always instruments for engagement, like the student engagement instrument or the user engagement scale. Very important to think about this. You need to use all those validated instruments. So well-designed measurement helps you capture the full impact of the AI-based tool, both in terms of academic results and broader outcomes like student motivation or engagement. So these are the learning outcomes, the primary outcomes. These are the core indicators of whether the AI tool is improving student achievement, because the measurement options here are pre-test or post-test assessments, the custom design subject-specific tests, which are aligned with curriculum designs, curriculum standards, and here these assessments measure the same competencies, of course, should measure the medical competencies at both time points. So pre and post-test assessments of grades, 10 grades of assignment scores, which is useful as supplementary outcome data. You need to ensure, in any case, that assessments are valid, measure what they intend to measure, and reliable. Reliable means that they yield consistent results over time. For engagement motivation, the secondary outcomes, since AI tools aim often to personalize or enhance learning, you should measure how students interact with and feel about the learning process. So here we use validated instruments. I mentioned about the student engagement instrument, very, very important, which measures cognitive emotional engagement, or user engagement scale, which measures focused attention or perceived usability, the Likert scale items. And also we can leverage the logs from AI tool. We can track engagement behavior, login frequency, duration of use, etc. These are related with quantitative tools, but we can use also qualitative tools for engagement and motivation. For example, we can ask some observation I mentioned before. We can use structured rubrics to assess visible engagements, the attentiveness, the participation, or focus groups. We can ask students how they feel about learning with a tool, the perceived usefulness and challenges. So the tip here is to try to combine subjective self-report with objective behavior data for a richer picture of engagement. This is the tip for this. And additional data sources, this helps you understand the context and user experience of the AI tool. So teacher feedback, surveys or interviews on ease of integration, the perceived benefits, the structural challenges, the student interviews or focus groups, these try to collect insights into motivation, to self-efficacy, the perception of adaptiveness, etc. And triangulation, which is crucial in research when we try to use multiple data to cross-verify findings. And this is important. Why? Because it reduces bias and improves confidence in our results. For example, if test scores go up, this is quantitative. Usage logs show high tool interaction. This is behavioral. And student interviews reflect enthusiasm. This is qualitative. And then it's a strong evidence of impact. So this is the example here, quantitative, predicted score, engagement scales. What is the purpose? To measure achievement. Behavioral, when we try to use logs or time on task, then we track actual tool use. And qualitative, with interviews and classroom observations, we try to understand student and teacher experience. And behavioral metrics, these offer a rich real-time data about how students interact with the tool. The key metrics to consider here is time on task, for example, the total minutes spent on learning activities, completion rates, percent of task or module finished, hint usage, how often students request hints or help, the error patterns, repeated mistakes or revision attempts, and adaptive pathways, how students navigate through personalized content. So the tip here is to set thresholds for meaningful use. For example, to say at least 20 minutes per session or 3 times a week when you analyze effectiveness. So a summary table for this could show, for example, the output time, type, academic learning, the example tools, the standardized test that we mentioned, the grades, the purpose to measure achievement change. For engagement, we mentioned what is happening with the classroom observations. We try to assess behavioral and emotional engagement. The behavioral analytics, so we use the tool also, the time on task, task completion. We try to capture real user persistence and contextual feedback when we have the interviews and focus groups, and we try to understand usability and barriers. So then the next step is what? Is to implement the intervention. Train teachers and students on how to use the tool. Try to clarify the duration. That could be 1 to 2 semesters. Monitor fidelity to ensure that the tool is used as it is intended. And then you add structure for what? For implementation protocol. This is the step-by-step guide for how and when the tool is used, and take support plan when you try to anticipate issues like connectivity, logins, etc. So this phase, the fifth stage is about putting your plan into action, ensuring that the AI tool is introduced into classrooms systematically, consistently, and with enough support to allow for a fair evaluation. So train teachers and students, why it matters? Because even the best designed AI tool won't be effective if users don't know how to use it correctly or confidently. And this includes what? This includes orientation, sessions for both teachers and students, or hands-on practice with the tool, or clear expectations of frequency and duration of use, or structural integration guidance, how the tool fits into daily lesson plans. Second is related with specifying the duration of intervention. It's important because we need a defined timeline to measure impact meaningfully. An example, the length, the schedule, and the consistency. All participants in the group should follow the same schedule. Then we need to monitor fidelity or implementation. Fidelity refers to whether the tool is used as intended. If one teacher uses it daily and another rarely logs in, then your results may be distorted. So how to monitor this? You can automatically track frequency, duration, and module completion by using logs, or you can, through teacher check-in or for classroom observation, we can use simple rubrics to see the tool is actually used as it is intended, as planned. And you may exclude low fidelity classrooms from some analysis or note them in the subgroup analysis. Then we have implementation protocol, which is a structured plan that ensures standardization across classroom or schools. This should include daily schedule for the AI tool usage, instructions for logging in and beginning activities, rules for when the teacher should intervene, and guidance for blended learning, how AI activities complement AI instruction. Then the tech support plan, even the best implementation plan can have issues, can present issues if there are technical glitches, etc. So here we need to include the preparation checklist if all our devices are refined and updated, if there is a stable internet access. Then we have a troubleshooting protocol that teachers should use if the tool isn't working, what they should do, what is the process. The common issues of quick fixes, the password resets, etc. The backup plan. There should always be a backup, an offline or alternative activity if the tool becomes unavailable. It is not possible to use it. For this, the tip could be to assign a point person or a digital lead in each school or in each class to act as a liaison with technical support. So the summary table is that first, the teacher-student training is important because it builds confidence. And here, for example, we have the support materials, orientation, the guides. We need to specify the duration. We need to ensure the valid comparable use of the tools, implementation fidelity through teacher surveys, observations, implementation protocols, standardize when and how the tool is used. So this requires a step-by-step classroom guide and tech support plan, which minimizes disruption from our technical issues. Here we can use a contact list, contingency plans, backup plans, etc. Then the sixth step is related with data collection. Pre-test first data collection to establish what we call baseline. We try to collect continuous online data during the intervention through observation, through logs, and then we have post-test data collection after the intervention period. Here you can also use immediate intervention checkpoints when we try to evaluate real-time issues and adjust if it's needed. And what we call blinding, those assessing outcomes shouldn't know group assignments to reduce bias. So this is also important to have in mind. And first, the pre-test data collection. We try to measure students' knowledge and skills and attitudes before they begin. Then what we do, we can give them a standardized or curriculum-based assessment, both across control and intervention groups. We can collect then student demographic data, the gender, economic status. Then we can distribute pre-intervention surveys on student engagement or self-efficacy. Then the ongoing data collection during the intervention. Here we try, what is the purpose? To monitor how students and teachers are using the tool and how students are engaging. So what to collect here? We collect engagement logs, the time spent, the number of activities completed, the classroom observations, structured observations using the rubrics to assess engagement, and tool usage fidelity of teacher diaries, record how the tool is being used and any instructional adaptations made. Why it is important? Because this allows you to identify patterns or issues that may influence effectiveness and ensures that the intervention is being implemented as planned, what we call fidelity monitoring. And intervention checkpoints. The purpose here is to check progress and resolve emergent issues and adapt if it's necessary. So what to include? We'll include quick diagnostic quizzes or formative assessments, or some teacher-student surveys to collect the feedback, or some focus groups or interviews for qualitative feedback. And we can check also whether the tool is being used as it's planned. Why it is important? Because it enables course correction. For example, if students are confused or are using the tool, adjustments can be made midway instead of waiting until the study ends. And then post-test data collection, how we measure outcomes. Here the purpose is to evaluate the final impact of the AI tool. We can re-administer the same assessments that we use in the test. We can conduct post-intervention surveys on engagement, satisfaction, motivation. We can collect feedback on student growth and tool utility. We can interview a subset of students to explore the learning changes. And why it is important? Because post data shows what changed and allows you to directly compare to the baseline data. Then blinding, which is recommended for reducing bias. What is the purpose with blinding? Is to ensure that outcome assessors are not biased by knowing which students were in which group. So how to implement this? Keep evaluators unaware of group assignments or use anonymous student IDs rather than names. And why this is important? Because it prevents observer bias or expectation effects, where assessors might consciously or unconsciously score differently depending on what they expect from a group. So the summary table here is before pretest, what to collect, test scores, demographic info, baseline surveys. During the intervention, we have observation, teacher logs, midpoint check. Then here we use diagnostic quizzes, quick feedback surveys. After the post-test, we have a final test, surveys, interviews, and all phases. They can actually monitor fidelity, ensure data integrity, anonymize data for blinding if it's applicable. And the seventh step, it's, I think, very important, the data analysis. Analyzing data properly is essential to draw valid conclusions about the AI tool's impact. And this step involves applying the right statistical techniques, accounting for the study design, and ensuring transparency and robustness. So here we have first, we can use statistical tests to compare outcomes between intervention and control groups. That could be ANOVA, it could be regression. We can analyze engagement using descriptive and differential statistics or conduct subgroup analysis by gender, parent, team, etc. And we can include intent to treat analysis. What is this? Intent to treat analysis, that we analyze all students as originally assigned. Model level modeling, if using cluster sampling, this accounts for nested data, students within classrooms, and missing a data plan. So all these steps, especially we talk about statistics, the purpose here is to evaluate whether there is a statistically significant difference in learning outcomes between the AI learning tool and the traditional group. The AI tool group, I remind you, that is the intervention group, and the traditional group is the controlled group. So what are the methods? DT test, if we want to compare average post against test scores between the groups. The ANOVA, if we want to compare more than two groups or testing multiple conditions. The linear regression, we will use if we want to control for variables like prior achievement or age or economic status. And then we compare, for example, mean improvement in math scores for AI users versus control using a t-test. For engagement, the purpose here I mentioned is that we want to assess how students felt and behaved during the intervention. So the approach could be descriptive statistics, All differential statistics use ANOVA tests to see if engagement differs significantly by group. A correlation analysis, which is the link engagement scores with usage data or academic outcomes. For example, does higher AI tool engagement correlate with greater score improvement? Another step is the subgroup analysis to see, the purpose here is to see whether the AI tool works differently for specific groups. So subgroups might include gender or socioeconomic status or language background, and how to analyze it. You can use interaction terms and regression models and run analysis separately for each subgroup or include subgroups as a factor in ANOVA. For example, does an AI tool benefit low achieving students more than high achieving ones? And intent to treat analysis that I mentioned before in order to ensure unbiased estimates of the AI tool's effect. This is the purpose, to ensure unbiased estimates. So here means analyze all participants in the groups to which you originally assigned. And why it is, even if they didn't follow the intervention, for example, students who didn't use the AI tool, and why it is important because this reflects the real world effectiveness. The multi-level modeling, the purpose here is to account for the nested structure of the data, students within classrooms, classrooms within schools. And why it is important because students in the same classroom may be more similar to each other than the students in other classes. And if we ignore this, can lead to what we call inflated type 1 error, so false positives. A model structure example, level 1 for student level, test scores, the level 2, the classroom level, statistical tools that you can use, software SPSS. Another session will have the chance to explore also this and how this software works. A missing data plan. What is the purpose with missing data plan is to handle incomplete data systematically and avoid bias. Some steps to include: define a threshold for acceptable missingness, use multiple imputation or mean substitution for missing survey items, and perform sensitivity analysis. So try to compare results with and without imputed data. Why this is important? Because missing data is common education research. How you handle it is something that actually affects your results validity. And the summary table, if we put it all together, we can see that if we compare learning gains, what we can use, the test ANOVA regression, we want to analyze engagement survey results, then we have to use correlation technique, descriptive statistics, the test, evaluations of subgroups, we use stratified analysis of interaction effects. If we want the group structure, then we use multi-level hierarchical modeling. If we want to handle non-compliance, then we will use intent to treat approach. When we want to deal with missing data, then we want to use predefined plan, imputation, or exclusion. Example of analysis workflow, how you can do this. If you have a software, you can run a descriptive statistics to understand the equivalence. Then you conduct pre-post comparison for both groups. Then you use ITT principles to include or assign participants. Then you model data hierarchical ways. You analyze survey data to measure engagement. You explore subgroup differences and report missing data strategy and sensitivity tests. So this is the example of the flow. And finally, what you will do, you will try to interpret and report findings. Discuss whether this tool had a significant impact, if there is a practical significance, not just statistical significance. You can reflect on limitations, generalizability, for example. You can provide recommendations for educators or policymakers. So in any case, you need to distinguish statistical versus educational significance. Why? Because a small test score may not be meaningful pedagogically. And then include visuals, very important, because these visuals, the charts showing score changes, engagement trends, and all this enhances, of course, clarity. So after analyzing data, your goal is what? Your goal is to tell a compelling, evidence-based story. What do the results mean in the real world? And what should educators and decision makers do with this information? So discuss whether the tool has a significant impact. What to do is to summarize the key outcomes. If this tool will lead to statistically significant improvements in test scores and engagement, you can refer to specific statistical results. And the tip here is to use charts or graphs to visually show the gains between groups. Then, as I mentioned before, we need to consider the practical significance, not just statistical significance. It is important because a result can be statistically significant, but have a minimal real-world impact. So practical significance is related with effect size, with cost-benefit implications, with classroom impact, the time saved, etc. For example, although test scores increased slightly, students in the AI group completed assignments 25% faster and reported higher confidence. Reflect on study limitations, the sample size, be transparent about what might have affected your findings. Common limitations include, for example, the sample size was the number of students sufficient to detect a reliable effect. Can the results apply to other schools of grade levels or regions? Generalizability, fidelity to implementation. Did all teachers use the tool as intended? Data quality. Were there missing or inconsistent data? Were surveys self-reported? A short duration if the study was only one term or semester, long-term effects are unknown. So then we need to provide actionable recommendations because our findings should directly inform practice and policy. Then we can tailor our recommendations for different stakeholders. If we talk about educators, then we provide suggestions of how teachers can integrate the tool to daily teaching. We can recommend some strategies on this, we can give them feedback. And if we are addressed to school leaders or policymakers, then we have to highlight the potential for scale up. We can recommend pilot programs or further investment or targeted funding. For researchers, we can suggest future studies. Example of recommended example says that we recommend incorporating the AI tool in grade 6 math class, accompanied by training modules for teachers based on the observed 12% improvement in problem-solving skills and positive student feedback. So you can understand how all this works. We arrive at this recommendation after 8 steps that we have already mentioned before. The reporting tips. You try here to present both strengths and weaknesses, so use a balanced tone, both strengths and weaknesses. Charts, tables, and infographics help stakeholders quickly grasp findings. Tell a story. Try to tie together data, feedback, and classroom observations, and include real quotes from students or teachers if interviews or focus groups were conducted. Okay, some example of interpretation summary here. You can see, for example, this tool significantly improved math test scores by an average of 12% compared to the control group with a medium effect size. Students reported increased engagement and competence. While results are promising, the limited sample size and short duration call for further trials before broader implementation. As I mentioned before, we can express it is recommended to mention the weaknesses and the limitations. So here we say that we recommend piloting the tool in similar classrooms with professional development support for teachers. This is an example of interpretation summary. The ethical considerations are there. We need to obtain, of course, informed consent from teachers, students, and schools, ensure privacy and data security, especially with AI tools, and address potential biases in AI algorithms. So expand, if it's possible, to expand on equity, ensure that tool benefits are not skewed towards students with pre-existing tech skills, and expand on algorithmic transparency, be clear about how the AI adapts or personalizes learning paths. So the additional considerations that would be the pilot study first, test feasibility and refine logistics, teacher variables, try to track teacher attitudes, fidelity, intervention, adherence, because they significantly affect outcomes and the long-term outcomes. If it's feasible, try to assess retention over time, follow-up testing 3 times later. So this was more or less the steps. Thanks a lot for your attention. And we can discuss any eventual questions you may have.
Amazing. Thank you so much for this wonderful session, Dr. Rania. Really, I'm very sure our PhD students, lecturers, and other audience who are watching, I think even teachers will be motivated to pursue their PhD studies, and particularly in how to do research. Yeah. So today you have used this. You have shared about how AI tools can be used in research. Thank you so much for your wonderful presentation, and we are looking forward to your next session, Dr. Rania, next Thursday. Dear audience, thank you so much for joining us and for your support. Please do not miss our session every Thursday at 6 p.m. IST. And for those who missed all our sessions, let it be forum, STG forum, or even professional masterclass, you can always go to our YouTube channel, Elegant Empire Education, and you can see there, and you can share and like our YouTube postings. Thank you so much.
Thank you very much.
Thank you so much, Dr. Rania. Thank you so much for this wonderful session.